Good day, ladies and gentlemen. Today we're going to talk about Unit 0, Lesson 3, which is multiplying and factoring polynomials. This is certainly something that you've done many times in Algebra 1 and Algebra 2. So it's going to be good to really review these skills. So let's jump right in. And before this, the first page here is about multiplying polynomials. And where we want to end up with is not so much multiplying, but factoring. So this is the page that's going to be more elusive than the multiplying, because everyone's good at multiplying. This page here is like, boy, needs some help. So let's start off, and you know the FOIL method. The FOIL method says you're going to multiply the first terms, the outside terms, the inside terms, and the last terms. And we can certainly use the FOIL method. I don't mind. So let's go about it. So I've got 2x times 4x, that's 8x squared. I have 2x times 3, 6x. And I have negative 7 times 4x is negative 28x. Negative 7 times positive 3 is negative 21. Now I'm simply going to add those, simplify that expression by adding like terms. The only like terms we have is the 6x and 28x. This is the step right here. I want you to be cognitive of this step. This is the step here that when we're factoring, use the AC method, is the most important step. But let's go ahead. We're not factoring yet. We're still just multiplying. So let's add the like similar terms. I have 6x, I have positive 6x, negative 28. This is going to be negative 2x, and then minus 21. Okay. On the next page, we're going to go here and end up here. This page, we're going starting here and ending up here. Okay, let's do another example. This example here, I have 15x squared minus 35x plus 9x minus 21. All right, simplify like terms. What do you get? You get 15x squared. Negative 35 plus 9 is going to be negative 26x minus 21. All righty. This example right here, this is a lot of people do not make this error. That does not equal 4x squared plus 49. That does not equal that. That's not 2x squared plus negative 7 squared. We're just simply, before I do this, I'm going to have to write this as 2x minus 7 times 2x minus 7 by the laws of exponents, by the definition of what an exponent is. And now I'm going to add this. Now this is going to be first term 4x squared, outside terms negative 14x, inside terms negative 14x, last terms positive 49. So a simplified like terms, this is going to be 4x squared minus 28x plus 49. Okay. Now I notice here on this particular example that I have 5x minus 3 times 5x plus 3. That's the example of multiplying a binomial to its conjugate. Let's just see what happens. First terms, 25x squared. Outside terms, positive 15x. Inside terms, negative 15x. Last terms, negative 3 squared, 9. If I simplify this, what do I get? I get 25x squared minus 9. These two terms we know add to 0. In like manner, that's exactly what we're doing here. I have a minus b times a plus b. Again, I'm multiplying two conjugates. What do I get? I get a squared. A times b is positive ab. Negative b times a is negative ab. Negative b times positive b is negative b squared. Again, these guys add to 0, so this is going to be a squared minus b squared. This is what we call a difference of squares. And whenever you have a difference of squares, factors to conjugates. So a squared minus b squared is a minus b times a plus b. A couple more examples on the multiplying. Are you kidding me? No, I'm not. Oh, no. For a moment there, I didn't think I was recording, but I think I am recording. Yes, I'm still recording. Just relax. Oh, my goodness gracious. I was all freaked out there. Anyway, let's do a plus b squared. In like manner, these guys are going to be similar. So this is going to be a plus b times a plus b. This does not equal a squared plus b squared. But I'm going to use the definition of exponents. I had the base a plus b times a plus b. And we're going to multiply that out. That's going to be a squared. I'm going to have ab plus ab is plus 2ab plus b squared. All right. I like this tagged up here. That way I know how much I want to spend most of the time on this video doing factoring. Okay, so here I have 5 times, I have 3 factors here. 5 times x minus 4 times 2x plus 3. First thing I'm going to do, I'm going to pull that 5 out here and in big brackets, and I'm going to multiply these two binomials. That's going to be x times 2x is 2x squared. X times 3 is 3x. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12. Close my bracket. Simplify what's inside the brackets. 2x squared. 3x minus 8x is negative 5x minus 12. And I'm going to multiply through by the 5 now. And looks like I have 10x squared minus 25x minus 60. This one here is going to be a little bit confusing for some students, but you're going to go about the same way. You're going to multiply these binomials first. Then we'll run through the negative sign. So this is going to be 3x times negative x, which is negative 3x squared. 3x times negative x. Then I have 3x times 5 is positive 15x. 3x times negative x is negative, 2 times negative x is negative 2x. And 2 times 5 is 10. Let's not run through the negative yet. Let's simplify what's inside. 3x squared. 15x minus 2x is positive 13x. Plus 10. Now I'm going to distribute the negative side. And what do I have? I have 3x squared minus 13x minus 10. All right, very good. So this multiplying is going to be, I'll let you pause that here a minute. This is going to be fairly straightforward. The factoring quadratics is going to be a little bit, it's tough for students, but confident that you can do it. Let's go to the factoring page. And what we're going to do is we're only going to factor using the AC method, because you can use the AC method to factor any trinomial. So the AC method is this. The first thing I need to realize is that all trinomials can be written this way. AX squared plus BX plus C, where A is the coefficient of the x squared term, B is the coefficient of the linear x term, and C is the constant of the trinomial. So we're going to pick out the A, the B, and the C. We're going to factor this guy right here. And here I have A is equal to 2, B is equal to 19, and C is equal to 24. The AC method tells me to find the product AC. Well, A times C is going to be 2 times 24, which is 48. What I want to do now is I want to find two numbers. I want to find two numbers such that P plus Q is equal to B, which is 19, and P times Q has to equal 48, A times C. So P plus Q has to equal B. This is B in our case. P times Q has to equal A times C. And now all I have to do is guess and check until I find those two numbers. All right, so I'm thinking about it, two numbers. Okay, what two numbers multiply together to 48? They add, oh, I know. How about 3 and 16? So true or false, 3 plus 16 does indeed equal 19. Nice. And 3 times 16 does indeed equal 48. So now, since I have the P and the Q, here's what I do. I'm going to take this 19, I'm going to divide it, I'm going to separate it from the P and X, QX. So I have 2x squared plus 3x plus 16x, and I still have this 24. So this is what happened. These two guys here, 3x plus 16x equals a 19x. And I do that because the next thing I do is I'm going to factor by grouping. I'm going to look at these two guys. I'm going to look at these two guys. And I'm going to look at these two guys. Be parentheses, really. And I'm going to factor out the greatest common factor. So what's the greatest common factor of 2x squared and 3x? It's simply just going to be an x. And here's what's nice. If I can find the P and the Q, and I could in this case, I absolutely could. Where I have this factor of 2x plus 3, it has to appear over here as well. And it does. And now you just simply ask yourself a question. What times 2x is 16x? What times 2x is 16x? You betcha. And positive 8. And now you check. Does 8 times 3 equal 24? You bet. So now I have a factor. I have two terms here. I have x times 2x plus 3, and I have 8 times 2x plus 3. So I'm going to use the reverse distributive property, and I'm going to factor out that 2x plus 3. And that's the factorization of that rascal. Okay? Now here, this is a good example here. What I want to do before I do this, and I always, step number one is always going to be factor out the greatest common factor. Well, look, I have, and this is going to make this problem easier. There isn't an x in all of them. There isn't a 4 in all of them, but look, there is a 2. So the first thing I'm going to do is factor a 2 out. Now I'm going to factor this rascal by the AC method. So I have A is equal to 2. B is equal to 19. Just a coincidence, the same B's are the same. And C is equal to 35. And so I find A times C. A times C is equal to 70. And I want two numbers, P plus Q equal 19, and P times Q to equal 70. Erase that. And let's find those numbers. Okay, you've had some time. Found them. How about 5 and 14? 5 plus 14 does indeed equal 19. And 5 times 14 does indeed equal 70. So I found the two numbers. So let's not forget. So let's go back over here. Don't forget about this 2 over here. So I'm going to do a big bracket here, but I'm going to divide the 19x up into 5x. Do this in blue. 2x squared plus 5x plus 14x plus 14x plus 35. Close the big bracket. Just, you could always write the 2 at the end. And notice that these two rascals here, this is what is equal to my 19x. And now I'm going to factor by grouping. I'm going to look at this. I'm going to look at these two terms and these two terms and factor out the greatest common factor. And the greatest common factor here is simply an x again. This is going to be 2x plus 5. The 2x plus 5 has to come up again. And 7, oh my goodness, yes. X times 2x plus 5 is 2x squared plus 5x. And positive 7 times 2x is 14x. 7 times 5 is 35. So now I'm going to do the final factorization here. I'm not going to forget about my 2. But I'm going to factor the x plus 7 out times 2x plus 5. And that's the final factorization there. Okay? All right, you can pause the video if you need to catch up with your notes. That's what's really nice about having the videos. If you ever need to pause the videos, just as we did before, just pause the videos, catch up with your notes. Think about what's going on. You need to take good notes. All right, so let's factor this guy right here. Let me separate this problem because this guy here is making me nervous. All right, so I have A is equal to 5, B is equal to 3, and C is equal to 4. Use the AC method, and I have A times C is equal to 20. And now I want two numbers. When I add them together, they equal 3, and when I multiply them together, they're going to equal 20. Well, tell me, ladies and gentlemen, boys and girls, friends and neighbors, dude and dudettes, cowboys and cowgirls, are there any two numbers that add up to 3 that multiply together equal 20? The answer to that is a big, giant, absolutely not no. If you have a quadratic and you cannot find the P and the Q 100% of the time, you can say the quadratic is prime. And so that's a prime because P and Q does not exist. Okay, as I do on many videos. So if P and Q doesn't exist, the polynomial is prime. The trinomial is prime. I am going to let you try the AC method on this dude. I'm going to let you try the AC method. I'm going to let you try to factor that. What I would do is pause the video. Pause the video. Try to factor this. back. I like to pause the video, and you should get this answer right here. Okay, so there will be some assignments associated with this rascal, and that's a nice video for lesson.